All right, guys, let's do homework 6.1. Let's put your name, your period number. Let's say I'm in block 1, 2. All right, so remember what we talked about today, whether something is a function or is not a function. The x's have to be, each x has to be matched up with one and only one y. So let's think about this. A stamp machine, let's use metacognition. Let's stop and read our instructions and really visualize what's going on. A stamp machine at the post office works very much like a vending machine. You press a button to select the type of stamp you want to buy. The diagrams below show the buttons and types of stamps for one machine. All of the stamps cost the same amount of money. Okay, so that's probably pretty important. All of the stamps cost the same money. Draw arrows from the buttons to the stamps in the diagram below to show a relationship. So I guess I've got button A, button B, button C, button D, and button E. So think of this as one big machine. Okay, so this would be my input. Would this be my independent or my dependent variable, guys? Good, that's the independent. He's in charge. Independent, which is also known as my x. So that we've got our input, our independent, our x. These buttons are in charge of what kind of stamps come out. Well, for it to be an actual function, if I press A, I get one type of stamp, flag. B, one type, president. C, I'm always going to get Elvis. If I press D, I'm always going to get a flower. If I press E, I'm always going to get the forever stamp. Okay? All right, so if this is my input, my independent, and my x, then this comes out of my machine. That's my output. That's my dependent variable. And that's my y. This guy's not in charge. He's like, listen, you push a button, you tell me what to do. All right, draw arrows from the buttons to the stamps in a different way than you did in part A to show a relationship that is a function. So it is a function again. We can draw any arrows we want as long as there's only one arrow coming from the A. So if I press A, I can come over and hit Elvis. B could be the flag. C could be the president. D could be the forever, and E could be the flower. What has to happen is make sure you only have one arrow coming from each letter. If I added another arrow right here, that means when I press C, I don't know if I'm getting the president or Elvis. So cross that out. Okay, you have to have one arrow coming. All right, draw arrows from the buttons to the stamps in a different way than you did in part A and part B to show a relationship that is a function. So again, you can do anything you want. You can connect these any way you want as long as each letter is only connected to one variable. Okay? Each input has to be connected to one output. Notice how everything's has something to plug out. I'm sorry, go back. Everything has a function. If I hit A, I'm going to get a flower stamp. If I hit D, I'm going to get an Elvis stamp. If there was another letter here, and I pushed that F and nothing came out, would that be a functioning machine? No. Every input must have exactly one output. If I hit a button, I know exactly one thing's going to happen every time. Create an example of that. Create an example of a relationship that is a function. Your example cannot be one of the ones we did today, okay? Well, let's say that if I hit A1, B1, C1, D1, and E1 in a vending machine, and I can get Snickers, and I could get Skittles, I could get Oreos, I could get an apple, or I could get Cheetos. E1 can be apples, D1 can be Oreos, C1 could be Cheetos, B1 could be Skittles, A1 could be Snickers. This is a function because every time I hit A1, I know I'm getting Snickers. Every time I hit B1, I know I'm getting Skittles. Every time I hit C1, I know I'm getting Oreos. Okay? All right. Next part. Create an example of a relationship that is not a function. All right, well, let's take that same one. A1, B1, C1, D1. And let's say there's apples, bananas, grapes, and what's the last fruit? Star fruit, which if you've never had it is delicious. So let's say that B1 is bananas, A1 is apples. When I hit C1, I could either get bananas or grapes, and D1 I'm going to get star fruit. Here's where the machine breaks. If I hit C1, I don't know if I'm going to get bananas or grapes out of this machine. And so that is not a functioning machine. Explain why your example is not a function. Because the input of C1, that's a 1, could give two different outputs. Not allowed to happen, okay? Not a function. All right, Miriam is an aspiring meteorologist, okay? She makes a table in which she numbers each day of the current calendar year from 1 to 365 in the input column. She records the corresponding high temperature in her town for each of these days. Does Miriam's table represent a function? Answer yes, no, or maybe. Well, I read for understanding. I know that my input column is going to be days. So my input is day of year. Okay, and it says she records the corresponding high temperature in her town. So this is the high temperature. So the day of the year is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way to 365. Now the high temp on day 1, let's say it's 70. Let's say it's 75, 80, let's say it's 75 again. And let's say it's 70 again. If I look at day 1 of the year, do I see any other ones? Nope. If I press 1, or if I choose day 1, I know I'm only going to get one high temp. There can only be one high temperature each day. So yes, this is a function because each day of the year will be matched with exactly one high temperature. Okay, Miriam wonders whether the table would be a function if she reversed the input-output columns. If the input column contained the daily high temperature and the output column contained the day of the year. Okay, so my plan is to recreate this, but flip-flop it. So over here, I'm going to write the high temp. And here I'm going to write day of the year. So my high temp went 70, 75, 80, 75, 70. And it went 1, 2, 3, 4, 5. Well, look at this. If I choose a high temp of 70, I could have gotten either 1 or 5. So think about a machine. If I put a 70 into that machine, I can't predict what day I'm talking about. So 70, when I put that 70 in, who knows if I'm going to get 1 or 5. If I put 75 in, I don't know whether I'm going to get day 2 of the year or day 4 of the year. If someone says, oh, the high temp was 75, I can't tell for sure what day they're talking about. So this is not a function. Because each input can be matched with more than one output. All right, that takes care of that. Let me give you some hints on staying sharp. For this guy, I would go ahead and make an XY table. When X is 0, Y is 0. When X is 10, Y is 5. Whoops. when x is 20, y is 10. So y is always, this number is somehow related to this number, and you've got to figure out how. Well, y, this number is always half of this number, isn't it? 5 is half of 10. 10 is half of 20. So y is always half of x, or 1/2 times x. Now use this rule to finish this up. We said in class that you don't have to do number 5. What you do here is take this algebraish and convert it into English. So V equals 0.10 times D plus 0.05. Well, V stands for the total value. 0.10 is the value of a dime. All right, you guys go ahead and finish. I'll see you in class.